Why does Edmonton's massive Commonwealth Stadium sit amid kilometers of seemingly empty parkland? Edmonton's Commonwealth Stadium, set to host 2026 World Cup matches, lies not in downtown, but inside the protected North Saskatchewan River Valley, a 30 km stretch of parkland, forest, and wetlands shielded from intense development. While the city averages about 200 people per square kilometer, the area right around the stadium drops to roughly 30 people per square kilometer, a contrast visible from orbit as a small concrete speck in a sea of green. To understand this low-density pocket, we need to look at deep time processes that create isolation cells on Earth. The channel's core idea, apparent emptiness, isn't accidental. It's an isolation cell where planetary thermal and chemical balances have sealed off complex biology, like the walls of a microscopic reactor preserving internal balance by limiting exchange. In Edmonton, the river valley acts as such a cell. Its alluvial soils, high water table, and regular flood cycles form a natural barrier that discourages dense urban sprawl. Its protected status reflects a long-standing geochemical equilibrium maintained for millennia, turning empty land into an actively regulated environment sustaining its own ecological rhythms. To quantify Edmonton's isolation, we use open data. The 2021 census block shapefile shows the nearest residential block centroid outside the valley is about 2 km from the stadium center, 53. 5,300 degrees N, 113. 5,260 degrees W. That's roughly a 15-minute walk or 12 football fields end to end a concrete isolation index we can compare with other landscapes. Population density inside the valley's core, aggregating 2021 census counts for all blocks within the official River Valley boundary, gives about 960 residents over 32 square kilometers, or roughly 30 people per square kilometer. A typical Canadian football field covers about 350 m². At that density, each field would hold only 16 people less than one person per 6 fields. Satellite images show the stadium's concrete ellipse surrounded by uninterrupted forest and floodplain, a pattern that holds season after season. By contrast, Edmonton's metro average is near 200 people per square kilometer, 40 times the valley's core. This comes from dividing the city's 2021 population, 010,000 by its land area, 845 square kilometers. The gap translates into real differences. Downtown bustles with transit, high rises, constant lighting, while the valley retains natural drainage, limited roads, and a soundscape of wind and water rather than traffic. A buried relic from the 1970s reinforces this low density. A former gravel quarry that supplied material for early city construction. After extraction stopped, the pit refilled with alluvial sediments and vegetation, creating a permeable yet stable layer about 8 meters below the modern playing surface. Geotechnical surveys logged this infill as a heterogeneous mix of sand, silt, and compacted clay, acting as a secondary barrier that limits groundwater flow and discourages deep foundations for high-density development. Landsat 8 and Sentinel 2 imagery from the past 5 years shows the quarry's footprint remains spectrally distinct from the undisturbed valley. The infill reflects slightly more in the near-infrared band, indicating different soil composition and moisture retention. Overlaying historic aerial photos from the 1960s reveals the quarry's outline matches the modern stadium's perimeter, confirming the arena was deliberately sited on reclaimed land. This alignment gives the foundation's uniform bearing capacity, simplifying engineering while preserving the valley's isolation character. Beyond urban planning, the isolation cell has ecological significance. The North Saskatchewan River Valley serves as a refugium for disturbance-sensitive species such as the northern leopard frog and several migratory waterfowl that depend on the valley's flood pulse dynamics. Research from the University of Alberta's Biological Station records higher biodiversity indices inside the protected corridor compared to adjacent urban zones, attributing this to limited human intrusion and the stabilizing effect of periodic river inundation. Thus, low human density is not a side effect, but a prerequisite for maintaining the valley's ecological processes. A common misconception treats such low-density zones as empty canvases awaiting development. The channel's formula rejects that view, emphasizing these spaces are actively regulated by planetary energy balances. In Edmonton, the high water table and seasonal flooding create a negative feedback loop. Adding impervious surface raises flood risk, potentially triggering costly mitigation and violating provincial floodplain bylaws. Hence, the isolation persists because the landscape itself enforces limits on human expansion, preserving safety and ecological integrity. To bridge the micro-macro gap, consider lithium atoms in spodumene, a mineral abundant in pegmatite deposits. In a perfect crystal, lithium ions sit about 3.0 A ring apart, approximately 0.3 nm. Scaling that atomic spacing up to the valley's low-density patch gives an equivalent distance between people of several kilometers, mirroring how the isolation cell keeps human particles far apart. Much like ions in a crystal lattice are held apart by electrostatic forces. This analogy makes the abstract concept tangible, linking stadium-scale urban planning to fundamental material science. The implications for the 2026 World Cup are both practical and symbolic. Building on an isolation cell means the stadium benefits from natural flood attenuation, reducing the need for massive artificial drainage systems. It also offers a unique narrative. Fans will experience a venue set within a living geological regulator, a reminder that even the grandest sporting spectacles are embedded in Earth's deeper rhythms. Moreover, the low surrounding density simplifies security logistics and provides expansive sightlines for broadcast cameras, enhancing the viewer experience without compromising the valley's protective functions. In closing, we return to the map that began our journey. As the imagery fades to a neutral grid, remember, this region is Earth's render limit. Next discovery, next topic. This region is Earth's render limit. Next discovery, next topic.